we have drawn these dotted lines, assuming that it is fully invisible. Actually it would be visible, that we have to find out the point up to which it is visible. So this is its front view and this is its top view. In front view also, with the same analogy, this is the visible end, visible up to this end, this one, and up to this end. So these are the three views of both the solid. Now to find out the points of intersection, let me draw imaginary lines or generators from this end. First we pick up this point. So this is point number 1. So from point number 1, draw a generator like this. Join this one with this apex point. It will cut this base somewhere here, right? This is apex point O dash and this is generator O1. So from point 1, draw straight vertical line like this. It will cut the meter line somewhere here, and from this meter line draw straight horizontal line like this, and it will cut this circle at 2 points. One point is here on the circle, another point is here. So it is 1, it is also 1. And from that point, so this is the generator. So join the generator with O. So that is the top view of this generator like this. Now draw this generator in front view as well like this. So from here draw straight vertical line. From here draw a straight vertical line like this, and draw that generator in front view. So this is the front view of this generator. Now from point 1, draw horizontal line that will cut this generator at 2 points. So these are the points of intersection. So that is regarding point number 1. Now what's about this point? Say point number 2. This is point number 2. So from point number 2, draw a generator O dash to 2, right? Project that point to again in meter line to top view, and in top view it will cut the circle at 2 points. One is here, another is here. So from these 2 points draw straight vertical line and draw the generator. From here draw straight vertical line and draw that generator. So this generator is also drawn. Now to find out the position of point number 2, from 2 draw horizontal line. So here would be the points of intersection on 2. Similarly, say this is point number 3. So from point number 3 draw imaginary generators, join O dash with 3, transfer that generator to top view and front view. So first transfer it to the top view, and after that like this, and it would be cut up to this end. It will cut this circle at this point. So here this is the generator, that imaginary generator in top view, and position of this generator in front view. For that, let me draw vertical lines from these 2 ends and join that with the apex point O dash, this point with the apex point O dash, and horizontal line from point 3. So it would be somewhere here and somewhere here. So that we have located. Similarly, point number 4, it is here. Here is point number 4. So from 4, draw generator. It would be like this. From this point, draw straight vertical line. From this point, draw horizontal line. It would be here. It would be here. So join that generator. From 4, draw horizontal line. It would cut somewhere here, right? So as it's a cone, the curve of intersection would be the smooth line. So join all these points with the smooth curve, and it would appear like this, a smooth curve, and here a smooth curve would be there, and here to the back side join them with the dotted line, as it is invisible. So this is the curve of intersection in front view. Similarly, in top view also we can find out the curve of intersection by drawing projection line from each points, vertical from this point projection line. It will cut that generator over here. So to find out the position of those points, pick up each generator one by one. So this is the generator. Here is point number 1, right? So from this 1, draw straight vertical line, and it is on generator 1. So here is that point. So that would be somewhere here, here and here, and here also we can join all those points with a smooth curve, so it would appear like this. This would be full line, this would be full line, and here like this. Exactly it is drawn over here. So this is the curve of intersection shown by these red lines, and here also you can insert the dimensions. This is the front view, this is top view, and this is side view. You can name the views as it's a front view, it's a top view, it's a side view. And I hope the solution of this problem is clear to you. Now next problem, problem number 4. And for this fourth problem, the data is given like this. A cone with vertical axis is intersected by a horizontal triangular prism, edge of the base 30 mm. The diameter of the base of cone is 60 mm and height is 70 mm. If the base of prism is 20 mm above the base of the cone and a rectangular face of the prism is parallel to VP and contains the axis of cone, draw 3 views showing curves of intersection. Again here cone is given as a standing solid. It is intersected by a triangular prism. So this is new case, that is triangular prism of given dimensions, but here it is given that the base of prism is 20 mm above the base of the cone. So first we have to draw cone 3 views. After that, in the side view of the cone we have to draw a triangular prism in such a way that its base is 20 mm above XY line. So let me think about the problem. Steps for thinking. Standing solid is a cone, diameter 60 mm, height 70 mm. Draw top view, front view and side view by taking projections. Penetrating solid is triangular prism of 30 mm sides, and axis is 20 mm above the base of the cone, that is above XY line, and flat face is 20 mm above XY line. 2 cases would be there. One case is the axis is 20 mm above the base, and another case is flat face is 20 mm above the base, that is XY line. So both the problems would be different. So here we will consider the flat face is 20 mm above the XY line. Take projections, select appropriate points. So first let me draw top view of this cone. This is the top view of the cone, that is circle, and its side view should be drawn by taking projection from this top view like this, and horizontal line from this end, vertical lines, and we can draw side view of this cone, which is a triangle as represented over here, right? Similarly, its front view also we can draw like this. In intermediate portion it will not be visible, so knowingly I have skipped that portion, otherwise we have to erase that point. Now find out the axis of this cone. So from this point draw horizontal line or projection line, and this is the axis of this standing cone. Now it is given that a triangular prism base 20 mm above XY line. So above XY line at a distance of 20 mm, so this distance is 20 mm. At a distance of 20 mm above the base, draw horizontal line, and this line, consider this line as a baseline, and draw a triangle like this, such that the base is 30 mm and the base is parallel to XY line. So this is the triangle, side view of triangular prism, and from this ends take projection and draw its front view as well, and in this intermediate portion would be dotted line as it is inside this cone, so not visible. From here to here, dotted line, dotted line. Here also it would be dotted line. And similarly, by taking projection, we can draw its top view, and inside this cone the edges would be could be represented by the dotted line, as it is not visible, like this, right? And these are the ends, bases, circular faces of the cylinder, represented by lines in the front view. So this is the given data. Now to find out the points of intersection, what should we do? Again the same analogy, pick up each ends one by one. Say this is point number 1, right? This is say point number 1. Mark it as a point number 1. From this point number 1, join that with apex point O and draw imaginary generator like this. Transfer this generator to the top view like this, and in top view draw that generator, join with the apex point O, right? Now from here draw straight vertical line, from here also draw straight vertical line, and join that line with the apex point, and join that line with the apex point on this side also. So what we have done, we have drawn 3 views of this generator O1, right? After that, this is point number 1, so draw horizontal line from point 1, it will cut that generator, one point over here, another point over here. So this is point number P1 or P1 dash. Now similarly, to find out position of point number P2, so this is point number 2, join that point number 2 with O like this. From this draw that generator, so draw horizontal lines, cut it over here, so the same generator would be over here. After finding position of this generator, this is the generator, from to draw horizontal line, it will cut the same generator at this point, so point 2 also would be at the same position, point P1 dash and P2 dash, both are at the same point position. What's about this generator? So for this point, so say this is point number 3, so from 3 draw horizontal line, this is this generator, this one end generator, so here point number P3 would be there. So here join these points with the smooth curve, it would appear like this, on this side it would appear like this. So this is the curve of intersection in front view. Now to draw its curve of intersection in top view, from here draw straight vertical line, and this will cut from here, it will cut this generator, its generator over here at this point. Here is that point. Similarly from these 2 points draw straight vertical lines and join these points with a smooth curve, which would appear like this. A curvature shape would be there, as it is a cone like this, and here up to this curvature shape it would be visible, so join with the full line, join with the full line. After that it would be invisible, so to be represented by the dotted line. So this is the curve of intersection in top view. This is drawn problem. I hope this fundamental concepts is clear to you. Now insert the dimensions. In this case, this is the cone having diameter 60 mm, so you can write here 560. Height is given, that is 70 mm, so insert the dimension, write 70 at the middle, and this side length is 30 mm, so you can write here 30 at the middle, and this axis is at a distance of 20 mm above the base, so insert this dimension as 20 mm above the XY line. So this is the solution. 3 views are there. This is front view, this is side view, and this is top view. Now next problem. Problem number 5. A triangular pyramid with edge of the base 80 mm and axis 80 mm is resting on its base with an edge of the base inclined at 45 degree to VP. It is penetrated by a vertical cylinder of 40 mm diameter and 100 mm length. The axis of cylinder coincides with that of the pyramid. Draw projections with the curves of intersection. So here first we think about the given problem. Standing solid is a triangular pyramid 60 mm 80 by 80. Base on XY line and one side makes an angle of 45 degree with XY line. Draw top view, front view and in top view, front view and side view in such a way that in top view square makes an angle of 45 degree with XY line. Penetrating solid is a cylinder, diameter 40, height 100. Axis of both the solids coincides with each other. Take projections, select appropriate points. So let me solve this problem over here. Here a triangular pyramid is there which makes an angle of 45 degree with XY line. So first draw XY line, and with XY line draw a line which makes an angle of 45 degree with XY line. So this angle is 45 degree, and on this line draw a triangular prism or a regular triangle having side length which is given as 80 mm like this. So this is the top view of this given problem. A triangle with 80 mm sides. Find out its midpoint. This is the midpoint. The procedure to find out midpoint is to join the corner and the midpoint of the opposite side, and we can find out this is the midpoint, and from this draw a center line. Height is 80 mm, so at a height of 80 mm mark a point over here, join that point with these end points, and this would be invisible. This is front view. We will find out its top view as well, and here also its top view is given, that is a circle, that is cylinder. The top view of cylinder is a circle. So let me draw that circle over here having diameter. This is the circle